Hello everyone, I'm Sonali Pawar. This is our fifth lecture of AVE, Audio Video Engineering. We have seen Chapter 1, Fundamentals of Television. We have seen different terms regarding to the television, scanning principles. Then we have seen different three types, NTSC system, PAL system, and the third type we will see SECAM system here. We will go in details of the SECAM system, that is its encoder and decoder. This SECAM stands for Sequential Color with Memory. It was developed in the France and it was used in the France and its territories, much of Eastern Europe, Russia and Middle East and Northern Africa. In SECAM system, problem of phase errors are avoided or it is completely removed. This SECAM system, the fundamental difference between SECAM system on the other one hand and the NTSC PL system on the other hand is that latter transmit and receive two chrominance signals simultaneously, while the SECM system is sequential or memory, that is sequentially color with memory. Memory is sequentially color with memory. Only one of the two color different signal is transmitted at a time. As we have seen in NTSC, both the color different signal R minus Y, B minus Y, both the color different signal were transmitted, but in this particular SECM system only one color difference signal is transmitted at a time. The subcarrier is a frequency modulated by the color difference signal before transmission. We have to produce a modulation before transmission. The magnitude of frequency deviation represents the saturation of the color and rate of the deviation and its fineness. During the course of development, the SECAM system has passed through the several stages, and the commonly used system, which is known as SECAM3. There are a number of SECAM systems which are having different standards, but SECAM third system, that is commonly used in between the SECAM system. Some of the systems are having disadvantages, so that next system was developed just like that. Here SECAM third is a pretty good, or that is commonly used system. It is a 625 line 50 field system with a channel bandwidth of 8 megahertz. What we have seen now in this SEM system, the color difference signal, there are two color difference signal, R minus Y and B minus Y. Signals are band limited to 1.5 megahertz frequency, and these two signals are then applied to the modulators. As we have seen before, they are applied to the FM modulators alternatively with the help of electronic commutator switching at a line frequency rate. The use of frequency modulation, why we use here frequency modulation instead of QAM, PAL and NTSC, it makes the system less sensitive to pulse interference. Hence the phase errors are in transmission and are ignored. That's why we are using here frequency modulation. Here in the SECM system, some of the specifications are, as we have seen, its bandwidth is 8 megahertz and its video bandwidth is 6 megahertz, and it is having 625 lines and 50 field system. Okay, now we will see the encoder diagram or coder diagram of the particular SECAM 3 system. This is the functional block diagram, which consists of RGB. These are nothing but the three video inputs that we give to the that we are having for any video signals that are given to the matrix and weighing circuits. Then it will produce Y, DR and DB. DR and DB are different signals of these two signals, that is R minus Y and B minus Y. These two signals are DR, DB. Then Y signal is given to the delay line because it is directly transmitted, so there will be little bit delay in the DR and DB and Y signal, because DR and DB we pass it through the low pass filter, then we give it to the preemphasis, then we give it to the modulator, because while passing through all these blocks there is some of the delay, and Y signal we pass it directly to the adder. So to the signal DR and DB to reach to the adder, some time is required to produce that time for the Y signal, because we are not giving a filter or modulator to the Y signal. Y signal will directly to the reach to the adder. So to give the in phase, all these three signal in phase, we are providing a delay line to the Y signal, and then DR and DB signal we give it apply it to the electronic switch, then low pass filter, preemphasis, after modulation and after that it will be given to the adder, which will be transmitted, which will be having the signals, composite video signals. This SECAM system, the signal sound carrier is plus 55 megahertz relative to the picture carrier. The nominal color subcarrier frequency is 4.4375 megahertz, as explained later. Actually, two subcarrier frequencies are used here. We are using the two subcarrier frequencies over here. The Y signal is obtained from the camera output in the same way as in the NTSC and PAL system. Okay, Y signal, as we give R, G and B to three inputs to that particular matrix, Y signal is directly obtained from that particular output. However, the different weighing factors are used and the weighing color different signals are termed as DR and DB signals, where DR is equal to 1.9 R minus Y and DB, which will be equal to 1.5 B minus Y. Further, we will see how we modulate that particular subcarrier frequency. We produce a subcarrier frequency for the purpose of modulation, how that modulation process occurs. The use of FM for the subcarrier means that phase distortions in the transmission path will not change the hue of the picture area. That is nothing but the phase distortion in the transmission path. Limiters are used in the receiver to remove the amplitude variations in the subcarrier. The location of subcarrier, that is 4.4375 megahertz, away from the picture carrier reduces the interference and it improves the resolution of that particular video signal. We are using here limiters for the purpose of removing the amplitude variations in that particular signal. In order to keep the most common large deviation away from the upper end of the video band, a positive frequency deviation of the subcarrier is allowed for the negative value of the R minus Y. Similarly, for the different signal, a positive deviation of the subcarrier frequency, which indicates a positive B minus Y value. Therefore, the weighted color signals are DR, which will be equal to minus 1.9 R minus Y, and DB, which will be equals to 1.5 B minus Y. Here, the minus sign for the DR indicates that negative values of the R minus Y are required to give the rise to positive frequency deviation when the subcarrier is modulated. In order to suppress the visibility of a dot pattern on the monochrome reception, two different subcarriers are used. For the red difference signal, it is 282 FH, which will be equal to 4.40625 megahertz, and for the blue difference signal it is 272 FZH, which will be equal to 4.250 megahertz. This was nothing but the modulation of that particular signal, where we have produced a subcarrier frequency by using the oscillator. Then there is a phase difference, and whatever the output signal we have, output different signal DR and DB, we have given to the modulation block. The modulation process is done. After that, we are using preemphasis process here. You might have seen in the diagram that we are using preemphasis process. The color difference signals are bandwidth limited to 1.5 megahertz, as is usual with the frequency modulated signal. The SECM chrominance signal are preemphasized before they are transmitted. Means before before modulation we have to provide a preemphasis for the in this SECM chrominance signal. So on modulation, the subcarrier is allowed a linear deviation which is equal to 280 dr kilohertz for the different signal and 230 dB kilohertz for the blue different signal. The maximum deviation allowed is 500 kilohertz in one direction and 350 kilohertz in the other direction for each signal, although the limits are in opposite direction for the two chrominance signals. After modulating the carrier with the preemphasis and weighted color difference signal DR and DB, another form of preemphasis is carried out on the signal. This takes the form of increasing the amplitude of the subcarrier as its deviation increases. Such a preemphasis is called as high frequency preemphasis. It is further improves the signal to noise ratio and interference is very much reduced. Getting preemphasis. Now we will go in detail with the SECAM encoder. This is the diagram for functional diagram for SECAM encoder. Now we will see that particular figure is a simplified functional diagram of the SECM third coder. The color camera signals are fed into the matrix where they are combined to form the luminance signal, where luminance signal Y is equal to 0.3 R plus 0.59 G plus 0.11 B, and color difference signals is DR and DB. The SECM weighting and sign factors are applied to the color difference signal so that the same subcarrier modulator can be used for both the chrominance DR and DB signals. The ident signal is also added in the same matrix. An electronic switch which changes its mode during every line blanking interval directs the DR and DB signal to the frequency modulator in a sequential manner. That is, when DR is being transmitted on the line, the DB is not used, and vice versa. Sync pulse generation and control. The line frequency pulses from the sync pulses generator are passed through the selective filters which pick out the 272 and 282 harmonics of the frequency H. Then the harmonics are amplified and used as the two subcarrier references. As we use the subcarrier frequency, they are used as the two subcarrier references. The synchronization pulse generator also synchronizes the switching control unit, which in turn supplies the operating pulses to the electronic switch for choosing between DR and DB signals. The switching control also operates the circuit which produces modulated waveforms of the ident signal. These are added to the chrominance signal during field blanking period and before they are processed for modulation. The output from the electronic switch that passes through a low pass filter which limits the bandwidth to 1.5 megas, that particular filter's bandwidth. The bandwidth limited signals are pre-emphasized and then they are used to frequency modulate the subcarrier. Means the signal that we get after the electronic switch, that we band pass that particular signal, its frequency, band pass frequency is 1.5 megahertz. Then that band pass that bandwidth limited signal or the output of that particular filter we give for the preemphasis. After the process of preemphasis, it is given for the modulation of subcarrier frequency to the modular block. The modulator output passes through a high frequency preemphasis filter having a bell-shaped response before being added to the Y signal. We have done one preemphasize before the modulation. Here we are doing the one preemphasize after the modulation process, that is high frequency preemphasize filter we are using after the modulation process, which will be before giving to the adder circuit. The synchronization and blanking pulses are also fed to the same adder. Okay, the adder output yields the composite chrominance signal which is passed on the main transmitter. Okay, whatever the output of the adder, that is composite video signal or composite chrominance signal, not only the composite video signal, composite chrominance signal, that is then transmitted over the transmission. This is nothing but the SECAM encoder. Now we will see SECAM decoder. Now this is SECAM decoder circuits. This is the functional diagram of SECAM decoder circuit, which consists of composite color signal at its input, which is this receiver. At its input we are having composite color signal which will be given to de-emphasis circuit and bandpass filter. Some delay line is applied to the Y signal, then Y amplifier and notch filter. After that it is given to the amplifier. We are using amplifier and 64 microseconds of delay line. Original amplified output and 64 microsecond delayed output we are giving to the electronic switch. After that it is given to the limiter, discriminator and de-emphasis circuit. After amplifying all these signals, it will be given to the amplifiers and matrix, and we will get VR, VG and VB to its output. This is nothing but the SECAM decoder functional block diagram. Now we will see the functional block diagram in detail. In this functional block diagram, the chroma signal is first filtered from the composite color signals whatever the input to this receiver or decoder is nothing but the composite color signal we have seen at the end of the transmitter block or encoder block. Chroma composite color signal we were having at the output of transmitter, that is as input to the receiver circuit or decoder circuit. This composite video signal or color signal is first filtered and then band pass. The band pass filter, besides rejecting unwanted low frequency luminance components, has inverse characteristics to that of the bell shaped high frequency preemphasis filter used in the encoder circuit. The output from the bandpass filter is amplified and fed to the electronic line by line switch. We are having the one switch, that is electronic line by line switch, via two parallel paths. Okay, there are two parallel paths. It is given as the input to that particular signal is that is output of the filter signal. Filter block is given as input to this bandpass electronic line to line switch. After that, the 64 microsecond delay lines are ensured that each transmitted signal is used twice, one on the line one which it is transmitted and the second time on the succeeding line of the field. The electronic switch ensures that DR signal, whether coming by the direct path or by delayed path, always go to the DR demodulator. Similarly, DB signal are routed by to the DB demodulator. We are having two demodulator, DR modulator and DB modulator. Respective inputs we will give to this demodulators. That is redirecting DR and DB signals to the wrong demodulator. The output of each demodulator during the indent signal period becomes positive instead of negative going. If you interchange the inputs of this particular demodulator, it will be having difference in its output. It will become positive instead of being the negative. A sensing circuit in the ident module then changes the switching phase. The electronic switch directs the frequency modulated signal to the limiters and frequency discriminator. The discriminators have a wider bandwidth than the employed for detecting commercial FM sound broadcast. After demodulation, the color different signals are de-emphasized with the same time constant as employed while pre-emphasizing. As in other receivers, the matrix network combines the color different signals with the Y signal to give the primary color signals. RGNB, which controls the three electronic beams of the picture tube. It may be noted that SECM receiver requires only two controls, brightness and the contrast. Only these two controls are needed for the purpose of receiving at the receiver end of the SECM circuit, that is brightness and contrast, both the monochrome and color reception. For both the color and monochrome reception, the saturation and hue controls are not needed because the system is immune to this distortion. There is no distortion related to the saturation and hue. That's why there is no need of saturation and hue control. So this is so because the color signals are constant amplitude frequency modulated signal, whatever the color signal we will get at input, and the frequency deviations which carry color information are not affected during the transmission. As in other receiver, the matrix networks combine the color different signals with the Y signal to give the primary color signal RGNB, which control the three electronic beams of the picture tube. Okay, getting what is SECM encoder. In short, we will see what is SECM encoder. Here, the input is composite color signal. The chroma bandpass amplifier that amplifies the chrominance signal, that chrominance color signals, and avoid the interference of Y signal spectrum. The alternating DR and DB signals from successive lines are then switched along with the one line period delayed version. The output of this electronic commutator, we are using here an electronic commutator or we can call it as a switch. The output of it is lead to the color different channel that has FM demodulators and amplifier stages. The demodulated and amplified stages or color different signals are then applied to the color matrix, that is where G minus Y signal is recovered from the R minus Y and B minus Y signal. We get the G minus Y signal. The identification signal is then separated from video signal and it is used to trigger the monostable multivibrator. This monostable multivibrator that controls the electronic commutator to switch it on and define its sequences. Thus, in the final R, G and B matrices, the luminance signal Y signal and color difference signal, that is R minus Y and B minus Y signal, are then added to get the R, G and B signal. Thus, these R, G and B signals that we have added then are given to R, G and B video amplifier, then to the color picture tube. These signals are given to the color picture tube. When only monochrome transmission is going on, that is black and white transmission is going on, then the receiver only Y signal will be processed at the receiver. This time the chroma and the and pass amplifier, that should be turned off to avoid the colored interference pattern on the screen, because we want only the monochrome transmission, that is black and white transmission. This turning off procedure for chroma bandpass amplifier is done with the help of color killer circuit. We are using that color killer circuit which removes the color from that particular circuit and gives black and white amplified signal. This color killer circuit is active when only black and white signal, that is Y signal transmission and reception is going on. When we want the color signal transmission, then color killer circuit will be in off position. Okay. Thus, we can say this SEM system is free from hue errors and saturation errors, okay, which is due to the modulation of the color signals. Then there is no need of generating the local reference subcarrier signal. Then hue and saturation controls are also not required. Brightness and contrast controls are adequate, which after serves as a saturation controls also. Okay, getting the concept of SECM decoder. What is actually the SECM decoder? What we do in this particular SECM decoder? Now let us see some of the advantages of SECM system. This SECM system, use of FM makes the system free from phase errors. No crosstalk between color signals since they do not exist on the same line. Okay, their frequency modulation, so they do not exist on the same line, so there is no crosstalk between the color signals. Hue controls are not needed indeed in NTSC, but not needed in the PAL and SECM system. Saturation control is also not needed in this particular SECM control. Low cost than both NTSC and PAL system. Higher number of scan lines than the NTSC system. Now we will see some of the disadvantages of the SECM system. Half color information is lost on each line since one color signal is transmitted on each line. It is not suitable for studio use. Studios uses PAL and then transcode to SECM for SECM markets. Incompatibility between different versions of SECM, because we are having different versions of SECM. Just now we have seen the encoder decoder diagram of SECM 3 system. These were the advantages and disadvantages of this SECM system. Now let us see next point, that is comparison between NTSC, PAL and SECM system. We will see different comparison parameters related to these three systems. NTSC, first is NTSC. NTSC is nothing but National Television System Committee. Then we are having PAL system. PAL is nothing but the phase alternating line system, and SECM is sequential color with memory system. Now we will see different comparison between these three systems. First parameter is it is developed or adopted, where it is developed in which country. NTSC system is developed in US, PAL is in Europe, and this SECAM is in France. The number of lines, NTSC system consists of 525 number of lines, PAL consists of 625 lines, and SECAM is having 625 lines. Then we will see frames per second. For the NTSC system we are having 60 frames per second. For PAL system we are having also 50 frames per second, and for SECAM it is same as PAL, 50 frames per second. Means NTSC is having 525 lines and 60 frames per second, while PAL and SECM is having same 625 lines and 50 frames per second. The next parameter is color info transmission, whatever the color signal or signal we transmit, U and V or I and Q are used in the NTSC system, while U and V are used in the PAL system. In the SECM system, DB and DR are used, just like we have seen in this lecture. Before this comparison, we have seen DB and DR signal. These two signals are used for the color info transmission. Next is subcarrier frequency. There are different subcarrier frequencies for different purposes. They are 3.58 megahertz for NTSC system, 4.43 megahertz for PAL system, and 4.25 or 4.4 megahertz for SECAM system. Then we will see color burst, 9 cycles of subcarrier frequency for the NTSC, while 10 cycles of subcarrier frequency for PAL system. Here burst cycle of red and blue subcarrier frequencies are for SECAM system. There are different variants of different system. For the NTSC system, we are having 4.43J and M variant, while PAL and SECM having number of variants, that is B, D, G, H, I, N, M and NC for PAL, while B, G, D, K, K1 and L for SECM system. The cost for the NTSC system is very medium. It is medium cost. PL system is most expensive system, while SECM is least expensive system. We will see studio mixing. That is, it is easy to mix that particular picture signals in the NTSC system. In the PL system, it is having medium ease, while SECM is having very difficult for the mixing of that particular signals. We are having some more parameters for the purpose of comparison. One is channel bandwidth. Channel bandwidth for NTSC is 6 megahertz, while it is for PAL system is 7 megahertz and 8 megahertz for SECAM system. Then we will see sound carrier related to the picture carrier. It is 4.5 megahertz for NTSC, 5.5 megahertz for PAL system and 6.5 megahertz for SECAM signal, while luminance signal in case of NTSC system is Y, which is equal to 0.3R plus 0.59G plus 0.11B, while for PAL system that is equal to 0.3R plus 0.59G minus 0.11B, while it is for SECM system 0.3R plus 0.59G plus 0.11B, similar as the NTSC system. While Y signal bandwidth for the NTSC system is 4 megahertz, for the PL system is 5 megahertz, and for SCM system is 6 megahertz frequency. The luminance signal modulation in case of NTSC is Am negative modulation. For PL it is same Am negative. For SECM system we are using frequency modulation, means for PL and NTSC we are using amplitude modulation, while we are using FM modulation for SECAM system. Then we are having different color subcarrier frequencies. The subcarrier frequency for NTSC system is 3.579545 MHz. It for PL system is 4.43361875 MHz, and for the SCM system it is 4.43375 MHz. Chrominance signal in case of NTSC signal is suppressed carrier, that is QAM. It is same for the PAL system, but for the SECM system it is frequency modulated signal. Noise immunity for the NTSC system is very high. It is also very high for PAL, but it is very high, means but more than or higher than the NTSC and PAL in the SECM system. Then studio operating mixing is easy in case of NTSC and PAL, while it is difficult for the SECM system. Color reproduction in case of NTSC is good. It is very good for PAL, and it is excellent, mean better than PAL and NTSC. It is for SECM system. We have seen receivers control. The receivers control in the NTSC system is we can control brightness, contrast, saturation, that is color, and tint or hue. In case of PAL, we control only brightness, contrast, and color, that is saturation. But in case of SECM, we are having only brightness and contrast control. This is all about the comparison of NTSC, PAL and SECM system. Okay. In this lecture, we have covered SECM system, details about the SECM system, then SECM encoder, SECM decoder circuits, both the circuits we have seen in detail, and then we have seen advantages of SECM system, disadvantages of SECM system, and comparison between the three main systems, that is NTSC, PAL and SECM system. Thank you.